Okay, so welcome everyone to Chem 481. This is PChem 1, and we just settled that a third of you, no, maybe 40% of you are chemistry, 40% of you are biochemistry, 20% of you are material science, and 50% of you are terrified. And that's okay, we will work through the class. So let's go through things one by one. So first of all, who am I? My name is Pratyush Tiwari. So I'm an assistant professor in chemistry and biochemistry, and also in this institute called Institute of Physical Science and Technology. I'm originally from India. I came to the United States in 2007 for my PhD, which was in Southern California and Pasadena at Caltech. And then I spent a couple of years in Switzerland for a postdoc, which was awesome. Then a couple of years in New York City, which was also awesome. And then I've been here a little over 4 years. I do thermodynamics for a living, and I've been doing that since, I don't know, since high school. Well, I didn't have a living then, but since my early research has been entirely thermodynamics. I use thermodynamics to study how do proteins behave, how to design fancy materials. The interesting thing though is I realized when I was kind of like your age that I'm terrible in doing things in the lab with hand. Anytime I would try to polish a sample, it just kept getting worse and worse. But I was very good at coding, computer programming. So I started doing something called computational research. So I tried to simulate proteins and materials on supercomputers, which is a lot of fun. And maybe we'll talk about that sometime in the future. So so this class is really connected to my research. That's also why I like it. Does not mean I'm going to bother you with my research. We will have some research papers towards the end of the semester, but we will work through the class very, very gradually. So, and my office is in that IPST building over there, which is like the ugliest building on campus. It's really small. And if you go to second floor, there is no elevator. It's really, really old and ancient. It's by the goats and the horses, if you know the farm over there. So that's me. And we have a TA for the class. Where is Connor? Connor is in the back. He's my graduate student. Connor, what are you? Are you fourth year, third year, second year? Third year. He's a third year graduate student in chemistry. He's an expert on crystal nucleation. He tries to study, how do atoms suddenly moving along, form beautiful snowflakes or crystals and things like that. So, and Connor has TA'd this class last time, and students did not hate him. Let's put it that way, okay? He's likable. And so the class website for this class is, I already sent you emails, but I set up an alias so you can remember. Let's see if I got it right. Yeah. If you go to the ELMS page, you have the link to the class webpage. And if you get stuck about the class webpage, you have to contact me by email. So, and the class webpage has all the information that we need. Let me open it over here. One of the biggest problems in sharing a screen is you could have embarrassing things open, right? So one has to be careful. So if you go to my webpage and in teaching, I like this one more than ELMS because it's easy for me to modify. I can link things. It's really easy to do things over here. So this is the class webpage. And on the class webpage, we have the course syllabus. We will walk through it one by one. We will study we will go through all the things mentioned in the course syllabus. And so this is the website we will be using for all announcements. For example, if you see in the bottom over here, focus. In the bottom over here, we have the link. And as the class goes on, all PDF notes and video, if we manage to get the video going, I don't know if it's actually recording or not. Once the class finishes, you will see. They will be posted online. And I cannot promise about the video, though. The notes will definitely be there. So if the video is not working, which means it becomes a bit more important for you to attend, The notes are not going to look, I don't try to prepare notes in advance because that way I'm not engaged in the class. It's good for me to, the notes are basically a snapshot of what has been covered. So if you come to class, the notes will be much more useful. If you don't come to class, the notes won't be that useful, but we have the Slack channel for that reason. You can come and ask each other or ask me what went on in the notes. So then, so this website will be used for all the information. For homeworks, we are going to use Gradescope. Is there anyone who has not used it? A few of you. It's a bit clunky, but it's not that bad. So you will get the link through Elms, and basically you can use your phone to take a picture of your homework and just upload it, and you will get it graded back there. It's smoother because we don't really want to be sharing material, right? And it's also a lot of paper being wasted. And so it's smoother, you get your grades back quicker. So Gradescope will be used for that. And I'm going to talk about exams when I go through the syllabus, but if it's a take-home exam, then that will also be through Gradescope. Most importantly, Slack. Let's talk about Slack. Is there anyone here who has not used Slack before this class? Okay, few of you. Is there anyone who hates Slack after having used it? One person. Why do you hate it?
I don't know. I just feel like it's another app I have to use.
I know, but it's got Pakora's photos. It's got my dog's photos. That's nice, right? So that's a compromise. I know it's like another app you want to use, and it's like another thing trying to take in your privacy and everything. I hear that, but it makes it worthwhile. You have to bear with me. If you don't like it, I will give you bonus participation points or something at the end of the semester. But last year, Slack was so popular in this class. I still have a Slack channel set for last year's Chem 481, and students still come and ask me questions over there. It's been very, very useful. So let's see how the Slack works. So we have a general channel, right? So far, 55 of you have joined the general channel. 4 of you have not joined it. Is there anyone who has not been? Some of you might not have joined it due to laziness, which is sad, but okay. Some of you might not simply be unable to join it. Is there anyone who tried but could not join it? No one? Okay. So let's hope that everyone is eventually able to join it. I mean, 4 of you remain. If you do that, you get participation points already. So the Slack space has a few channels. There is the general channel in which I will just put announcements such as, by the way, can people in the back row hear me? Yeah, I'm loud, that helps, right? So in general, I will post things like, hi channel, how are you? No class tomorrow, or the homework is out. No, there is class, sorry. Next Monday, there is no class. It's holiday. So I will post general announcements. And then there is a homework help channel where you can really focus on questions about homework. Like, does anyone else think that problem number 2 on this homework is like wrong? Or something is missing? We could do everything in the same general channel, but just, it's like just putting labels on the things. It makes things a bit simpler. Then there is math help. In math, in a thermo, there will be a lot of math issues. So invariably, you can ask math-related things here. And it might be and sometimes it's not clear whether it's homework related or math related, doesn't matter. If you put in the wrong channel, it's totally okay. It's just to help you a little bit. If you want to ask questions specifically to TA, like when is your office hour? When is your office hour, Connor? Why have you not announced it yet? It will happen sooner or later. So that's how you reach out to Connor. And finally, this is the most popular channel from last time. This is my dog, Pakora. He is a little under 3 years old. His interests include skateboards, motorcycles. These are the 2 things he hates, okay? So if he sees you on a skateboard, he's gonna frighten you, believe it. And the other day, one of his friends came to our home in his car. His friends, meaning a dog named Brownie. And since then, he's convinced that every car he sees has Brownie in it. So now he's become crazy for cars also. So, it just keeps things a bit light. And he might come to one of these lectures to just say hello to you. So these are the 5 channels. All announcements will be posted on Slack. In the very beginning, I will be posting announcements through email also, then I will stop. Email is clunky. It just becomes hard to respond to things. The biggest advantage about Slack is if you miss my office hours or anything, just type in a question. I normally wake up very early. I can respond whenever you can ask your students from last fall. I typically respond quite quickly, except on the weekends if it's an emergency. So it really removes the boundary between, when are your office hours? Can I come meet you? So it makes me more accessible to you. So you can ask me questions very, very easily. Okay, I will be releasing a lot of practice problems as the semester goes on. One grievance students always have in PChem 1 or even PChem 2 is you do a lot of the material in the class and you get a hang for it. You're like, okay, I kind of see what's going on. And then you get the homework and it looks nothing like what you have done in the class. Have you experienced this before? Maybe in other classes, like, what is this homework? I have no idea what you're talking about. So these practice problems will kind of reduce this barrier. Okay, so the practice problems will be there. The condition on the, so I'm going to release the solutions to the practice problem. Typically the condition is that you have to try. One of you or two of you have to try and post a trial solution on Slack. And then I will release the, typically I will release even a video of me solving it. So not just a solution, but actually how did I think through it? How did I set up the problem? So I found this, that it's quite useful to students. And I really believe in feedback. I'm not one of those professors who just takes your evals and throws them in the trash. I will ask you for anonymous evaluations, probably 3 weeks from now. And be frank, tell me what you think I can improve upon, and I will try to do that. Okay, so my only objective in this class is actually for all of us to have fun. Okay, we have to learn and have fun. If you have fun, you can get an A in this class. And like I said, I'm very happy to give all of you an A if you meet the requirements that I am setting. That said, every year there are at least 2 or 3 students who fail this class. It breaks my heart every year to give an F grade in this class, but it happens. And the reason for that happening is they just don't submit homeworks. They don't show up for the final exam, or they show up to the final exam or the exams and don't write anything. If you do that, then I can't help you, right? I can't be giving you an A, so try. Every once in a while, homeworks will have bonus problems. Try them, okay? So you can make up for previous homework. So I will help you get good grades. You gotta try them along with me. Math. So there is a reason why math matters so much in PChem 1. And the reason is that PChem 1 is about thermodynamics and kinetics, right? And both of these are about change. Change as in not the change you carry in your pocket, but change as to how one material or how one chemical changes to another chemical. And once we finish the logistics, we will be going to all of that. So, and the mathematical language to study change is calculus, right? Calculus is how you study change. Geometry is not how you study change. Graph theory is not how you study change. It's calculus how you study change. That's why calculus becomes so fundamental to PChem. Another reason why the calculus becomes hard is because, like most things in life, PChem, I once had this t-shirt which said, life is not a calculus of one variable, do the math. It's always 50 things that are moving at the same time. Really, you can control the pressure on a system. You can control the temperature on a system. So you can't just do single variable calculus. You have to do something called multi-variable calculus. That makes things a bit harder. So last summer, what I did was to prepare a bunch of math helper videos for this. There are 3 playlists. The first one is just about functions, the basic concepts behind functions. The second one is single variable calculus. The third one is multivariable calculus. These playlists are all on YouTube, but if you go to the Elms page for this, you will find that I have also put in practice problems, and I have put in solutions to these practice problems. Let's go to student view to see how you see this. So if you go to the math modules, you can see there are playlists here. And if you click on fun with functions, for example, after every playlist, I have provided the notes in PDF. And in addition to the notes, I have also provided exercises and answers. So try to work through the exercises. You don't have to do all of these math playlists right now. I will be posting messages on Slack. This is a good, this is class, this is a good time to go through module number 1, okay? You should be comfortable with that. So what you can do is to open it up and see, okay, I already know all this. I don't worry about this, okay? Try some of the problems. If you're comfortable, then you don't have to worry about it. If you're not comfortable, please make sure to try them. Because the math in this class is I don't know how many of you are drinking age. Some of you, hopefully. Okay. It's like drinking a glass of wine, right? The first sip you have, like, it's not too bad. What's the big fuss? By the time you have finished first glass or the second glass, you start getting woozy, right? It's strong. It picks up. It's not like whiskey, where from the first shot, it's a boom. That's quantum mechanics that you will experience in 482, where the math will come and hit you from the very, very first class. But in 481, the math will pick up gradually. So be ready. I'm warning you. In 2-3 weeks from now, I can show you my notes, the typical notes, how they look. Let me actually show you. You will see what I mean. If you look at the notes from later in the semester, this is how they might look. Whoa, chemistry or math. So this might look like, what on earth is this? But if you stay with me, you will see what it all means. So that's what I meant. The notes will be posted online, but if your plan is to not show up to class and just open up the notes, it might be a bit hard, okay? And I don't know if the video recording is working or not, because if that works, that will simplify life. If not, what I'm going to do is to post the videos from last year when I was doing everything on Zoom. So those videos are there. And most of the time we will mirror the class flow will mirror last year. So the video, you won't be left, completely clueless. I'm there to help. So it's going to be a lot of math. And it's better to warn you now than later. Okay, what else? Let's go back to, okay, we went through math. Now let's go through syllabus. Any questions so far before we get into the syllabus? Okay. And often there will be, okay, let's start with the syllabus. Then I will tell you about this special ice cream deal in this class. There is a way to get free ice cream out of this class, and I will be telling you in a moment. So Chem 481 is really thermodynamics and kinetics. Most of the time we talk about thermodynamics in this class. If time permits, we will talk about kinetics, and there is a joke hidden in there because kinetics is the study of time. I don't know if any of you found it funny or not. Hopefully soon. So, and we will go into what this involves. So, as I will mention once again, that multivariable calculus is important. The material for that is all there on ELMS. Try to go through it because of these lists that we prepared. The book for this class is Physical Chemistry by Atkins. Any edition will do. Okay, the new edition online tends to be quite expensive, especially in the biochemistry majors must have experienced this. Like many of the biology books, if you buy the newest edition, it's $120 or $200. And if you go 2 editions behind, it's like $5 for a used book, right? Go ahead.
If you Google the name of the textbook, it gives you a PDF of the textbook.
It's probably illegal, so don't ask me. That's okay. I don't care. Yeah, I mean, sure, you can find. Yeah, so ask him. What's your name? JP? Yeah, ask JP for PDFs of the books. Don't ask me. Okay, great. So there is also a book for. Let's actually open the syllabus over here. So there is Physical Chemistry by Atkins. Any edition will do. There is a wonderful book for math for chemistry. This book, the PDF, is actually legal and available online. It's completely open source. And this book is wonderful. You can save a PDF. It goes over concepts in calculus from the point of view of chemistry. This is a book you will find useful also in the future. It's quite interesting that the guy who wrote this book, John Straub, was a chemistry major of UMD who took 481 many, many years ago and is now a professor at Boston University. That's kind of cool. So let's go to syllabus. Where did my syllabus go? Yeah. So that math book will have more material. If you go through my ELMS material that I've provided, the playlist and everything, you don't need to access that math book, but if you want, you can do it. It's not mandatory. And there are also other books. There is a book by Macquarie. I can post, if anyone of you wants advanced books to study in this course, I can post that on the Slack channel. I'm not going to overburden you with the advanced books for now. Atkins is okay. And in fact, if you don't, Atkins will be useful for you if you want to prepare in advance for the class. Otherwise, if you just come and attend, you don't have to worry too much about Atkins. it's worth buying a copy or contacting JP to get the PDF. Connor is the teaching assistant. He's known as UA, but he likes to be called Connor, and that's his email. It's zzou@turpmail. I will be holding office hours on Zoom. Okay, my office hours will not be in person; they will be on Zoom. Monday, which is today, 11 a.m. to noon. Okay, and the Zoom link has been sent out. It's also written in the syllabus, umd.zoom.us/my/ptiwari. Just click on it. I will be sitting there. You can come and hang out. Normally, Zoom has an explosion of students when homework is due or when homework has been graded and given back. That's what happens. But try to come and ask me questions that are not clear to you about the subject matter. And like I mentioned on Slack, anytime I'm happy to answer questions, even if I'm traveling or anything, I will always answer questions on Slack. Now, Connor will be announcing his TA hours. He will probably do sort of a poll to get a sense from you. His TA hours will coincide typically 3 days before or 2 days before the homework is due. I mean, that's what most students need it for. And attendance is encouraged, participation is encouraged. It's not mandatory. I will not be penalizing you for not attending. There might be reasons that you don't want to attend. However, I'm going to talk about participation points in a little bit. And I hope that the class is one of the feedbacks, course evals that I'm proudest of from last semester is that one student wrote that the class gave them a reason to wake up Monday morning, 9 a.m. and to come and attend. So I hope you also feel that way, but it is early and I get it. If you don't want to attend, that's fine. But go through, if the videos work, then that simplifies things. But hopefully the thing is, I mean, last semester, especially, raised an existential questions for all professors, right? What does it mean to teach if you can just go online with recorded videos? But it's become quite clear that engaging in a classroom is not quite the same as a recorded video, right? It's like doing a Zoom is not the same as hanging out with your friends in a bar or in a restaurant, right? We have come to appreciate how human interaction or interaction with a dog who might show up sooner or later is important, right? So come to class, stop me, ask questions. My favorite classes are those where one of you manages to totally trip me and confuses me. And I'm like, okay, I need to go and think about this carefully. It happens like once a semester. And I love it when it happens. And so come and engage and ask me questions. You can also do it on Slack after the class, but it's more interesting when it happens during class. And like I said, notes will be available as I start writing things, videos. Let's see how it works today. Cheating is not allowed. And cheating is surprisingly easy to identify in this class, even in take-home exams. These problems will be, there will always be problems which are kind of unique. And if you cheat and you try to copy from the internet, we can tell that you copied. And the way that's going to work, if I suspect any student has copied, I'm going to ask you to come to the blackboard and solve it in front of everyone. Simple deal. If you solve it, you get full participation points. Okay. And if after that you don't want to bother attending, cool. But it has something like this happened once. It was not in the context of cheating. Someone came and solved it and they got full participation points. But this student liked the class so much that they kept attending anyway, right? So if you're going to cheat and if you suspect, we will just ask you to come and solve it here and walk us through the steps. Okay. If you can cheat with that much confidence, okay, but try not to cheat. Your objective is to learn in this class, okay? And so cheating becomes especially easy, or it's an attractive thing. It's an attractive way out in take-home exams. And there will be at least one take-home exam. Try not to cheat, because even if you do cheat, there will be one in-class exam, right? And there is nothing, which will be closed book. So it's best if you just think through things. No exam will be such that you will be short on time. Okay, I will be giving I don't believe in giving you too many problems and just keep you going like super fast. Although, even though I say this, once I do give you the exam, some of you will invariably think that there were too many problems. Okay, but it won't be too bad. So you will have time, just think through things. And in the take-home exams, you will any take-home exam, I will give you a week to solve the exam, to take the exam. So you have lots of time, just think through everything. So which is a good point to now talk about problem sets and exams. So there will be 6 to 8 homeworks in this course, minimum 6, maximum 8. And it will depend on the pace of the class. The first homework will be released maybe a week or so from now. It will cover some of the math thing. So it will have some material from all of the multivariable calculus, the single variable calculus. So I make sure that you know that you are okay with the calculus and some chemistry. And cheating in homework sets. So in homework sets, you are free to discuss with each other as much as you want. You are even free to go and look up things if they are already posted on, I don't know, check.com or whatever. And if you want to copy from that, sure. Most problems will not be like that. So you can take help from wherever you want on the homework. It's totally fine, but try to make it your own work. If you're looking it up online, sometimes there will be problems just from Atkins. And if you can find the PDF to Atkins, you can most definitely find the PDF to Atkins solved problems also, right? So you can just copy from there if you wish. If you do that, it will make me sad. So try not to do that. But more than that, it won't get you a good grade. There will be one or two problems like that. You will have to think through. So if you do come across a solved solution, to a problem, it's natural that you just want to copy it, which try to at least express it in your words. This will happen one or two problems every homework. Most of the problems will require you to think on your own and discuss with classmates. If you study in groups, that's highly encouraged. Discuss with classmates. If you come upon a solution together, I mean, that's how research is done, right? We work in teams. Like Connor is my PhD student. I have 7 PhD students and 2 postdocs. We work on problems together. We solve them together. That's when we publish in a journal. So if you solve problems together, just make sure that your answer that you submit is your own work. Okay, don't just like copy together. Solve it together on Blackboard or whatever, set up Zoom session or whatever you do, but then your solution should be your own work. And exams, so there will be 3 exams. First midterm, second midterm, and a final exam. Each of them is 20% of the grade, which means that if you totally flunk in any of the exams, you can still get a B+. Okay, 20% of the grade is not going to affect you more than that. So no one exam is going to totally destroy your grade. So don't freak out. And oh, by the way, regarding homeworks, your one bad homework, your one worst homework will be excluded from the grade calculation by default. Okay, so if you do really bad in one homework, it won't even matter. So there are 3 exams. One of them will be in class. I don't know which one yet. I will let you know at least 2 weeks before the exam if it's going to be in class or not. One of them will be take home, where you will have lots of time to solve the problem. Take home exams tend to be harder than the in-class exams. Okay, in-class exams tend to be, I don't know, show this relation, prove that relation. Take home exams will require you to think really, really hard. When I was in graduate school, I had a professor teaching something called condensed matter physics. He gave a take home exam where one of the problems I just tried for like 2 weeks, couldn't solve it. And I go back to him, he goes like, oh yeah, if you would have solved it, I mean, a few Nobel laureates have tried to solve it. No one ever succeeded, that kind of stuff can happen. I won't do that, but they will be harder than the in-class exams. 30% is homeworks. So the homeworks matter a lot. And it's also easy to get to full 30% through the homeworks. So keep at it, keep doing the homeworks timely. That's how you learn a lot. And 10% is participation. So out of these 10 participation points, 2 points, most of you already have it by joining Slack. If you do it by Friday, you get the remaining 2. The final 8 participation points. Okay. The final 8 participation points will come by you doing 2 out of 3 things. Either you are regularly participating in class. How do I know that you are attending the class? You all have masks on. It's kind of hard to see, except I know JP is the PDF guy now, so I remember him. And he's the computer science guy. And she doesn't like Slack. What's your name? What's your name? Katya. So 3 people I know now. That's good. That's okay. I hope you like it later. But otherwise, you can just tell me at the. I will tell you once you reach 10 participation points, I will send you a message that you're good to go. If you haven't received that message, you can ask me. What do you have to do to get there? Okay. So by the end of the semester, most of you will get there, but we'll just make sure that you do the work. So either attend the class or ask questions on Slack and answer them. Liking Pakora's pictures do not count as Slack participation. These gotta be chemistry questions. Liking Pakora's pictures or sharing your dog pictures are actually highly encouraged. I mean, I have a whole collection of all the students' dog and cat pictures and rabbit pictures from last semester. And the third way is to come to my office hours and engage with me there. So if you cannot attend the class in person, that's okay. You can still get full participation points by asking questions on Slack or coming to my office hours. worst homework will be excluded from your grade. Good, so we are done with syllabus. Any questions about this? No questions? Okay, now let's start with PCAM. Next time I'm also going to bring, I guess I will resist bringing chalk. No, I'm not done yet. Don't go. We still have 10 minutes, 5 minutes. So I'll start, and next time we will really get into the hang of things. So let's start the subject matter today so I can get you a flavor for what this course is all about. So PCAM is really the study of energy. So PCAM, and every Slack, every class note I have specified on top. My handwriting is terrible. Please ask on the Slack channel if something is not clear. But last year, students did not end up asking that much on the Slack channel. They kind of got to terms with the handwriting. So PCAM is study of energy and how it changes, and if it changes. So I have two words here that need to be emphasized: how and if. And there is a third word that I would also like to emphasize, which is and when it changes. So these three things: how does energy change, if it's going to change, and when it's going to change. So within these three things, thermodynamics itself is the study of the how and if, and kinetics is the study of when. So the name thermodynamics is kind of, is my handwriting clear from the very back, or is it hard to read? Okay, good, thanks. Yeah, if anything is not comfortable or not clear, please just let me know. It's a strange semester, it's like first time I'm seeing so many humans live. It's like strange feeling. Who are you all? Can I just like blank the screen or something? No, it's not gonna work. So the thermodynamics is a funny name, right? It says dynamics, right? Dynamics means things moving, things changing, yet it does not talk about time. So in thermodynamics, there is no time. The notion of time comes into kinetics. Most of the semester, we will talk about thermodynamics. We will talk a little bit about kinetics in the later part of the semester, but it is really purely a study of change, how it happens, and if it happens. So the cool thing about PCAM is, as the name itself says, it's physical chemistry. So what do I mean by physical chemistry? It's really physics and chemistry mixed together, right? We are going to use the laws of physics to understand how chemistry works. So if you like physics, PCAM is probably going to be your favorite chemistry class. If you didn't like physics, it might not be your favorite chemistry class. But sooner or later, you will see that PCAM can be used to explain so many complicated concepts in biochemistry, in molecular biology, everywhere, that you will not hate it as much. So PCAM is really taking laws of physics applied to chemistry. Is my hand like really disconcerting on the screen? I find it very strange. Anyway, so now what do I mean by laws of physics? When I say laws of physics, what are the laws that come to your mind? Anyone? I heard something? Newton's law, right? F is equal to ma. What are the other laws that come to your mind? You can just speak out loud. Huh? Well, that's PCAM. Let's go back one step. Very basic physics, like ninth grade.
Acceleration is velocity over time.
That's still Newton's law. Go ahead. Newton's law. Think a bit broader. Go ahead.
Q equals MC delta T.
Q is equal to?
MC delta T.
I was looking for something specific. I was looking for quantum mechanics, right? That's the big one. This you should not forget. And does anyone know the most famous equation in quantum mechanics? Schrodinger equation, right? Have you seen Breaking Bad? Like Heisenberg, right? I could look like him. So Schrodinger's equation, H psi is equal to E psi. You have probably not seen this. You're going to see it in Chem 482. There is a third one, third law. Anyone remembers? The physics has many, many laws. I'm not saying these are the laws. You are all correct. The other laws you mentioned, I'm just trying to classify them. So there is, so this is classical physics. This is quantum physics. And there is a third type of physics. It's called relativistic physics, right? When Einstein, until 1905, there was no relativistic physics, right? So that was E is equal to mc square. So in 481, we are mostly going to be talking about applications of force is equal to mass time acceleration, F is equal to ma, Newton's laws, you know, the ones you mentioned, acceleration is equal to dv by dt. These are the type of things we'll be using. In 482, you will talk about quantum mechanics, H psi is equal to E psi, and Schrodinger's equation, and Heisenberg's uncertainty principle, and things like that. This is typically not covered in PChem because most of the time, these relativistic effects, we don't care about it a lot. Maybe in some courses it matters if you're interested in the early stages of the evolution of the solar system or universe, then you might care about the relativistic effects, but mostly we will not be talking about. Mostly we will just be worrying about Newton's law of motion. And through applying Newton's law of motion, we are going to study change, right? How to change one form of energy to another, and if such a change in energy is even possible or not. So next class, we are going to start quantifying all of this up. Next class, we will start by talking about things such as pressure, volume, temperature, number, and see you Wednesday morning.